Hey everyone. Hey everyone. I'm gonna be multi-streaming today, so have some patience with me with just setting things up, and I'll try to make sure everything is working well. Okay, I think we're good. Okay, I think we should be live on stream as well. I'm getting quicker at this. People that are gaming it multiple times. Uh, Getting pretty quick, I would say. Still not amazing at this. Definitely better. Just pull up, make sure everything's working. Pretty sure it is. But it's good to make sure. Because it'd be funny if I was just talking to myself without anyone watching, because, I mean, that's what it feels like to me. It feels like I'm just talking to people that, I mean, it feels like I'm talking to myself. There we go. I think we're all set. So quick at this. Let me just, yeah, it's fine. Share my screen. So, I think we're gonna continue from where we were at yesterday. We're implementing. Yeah, we're trying to solve this question, which was the daily question from yesterday. Uh, we didn't solve it in time. I mean, we just didn't solve it. We got the first part done, which is nice. But yeah, I missed the next two parts. So there's three parts to this question. There was batch gradient descent, mini batch gradient descent, and stochastic gradient descent. Um, so yeah, we're gonna just continue solving this. Could wait a little long for people to join. Also, no, not scale draw. Where's here? So now this seems to be rendering better. Probably wondering how I fixed this. I reloaded the page. Yeah. Hi. And sleepy. Let's see. Oh, I guess quick announcement. We have a giveaway. My results are not, I mean, they're okay, but I think the best is 95.6 right now. We have a giveaway where if you get in the top 10 percentile and you post it on X or LinkedIn and tag us, you could have a chance to win either a mug or a sweatshirt. Not sure who would rather a mug, but not judging anyone. But yeah, we have a few sweatshirts. The contest expires tonight. Probably should make a Cyber Monday deal at least for our merch. But yeah, so it ends today, EST time, 11:59 a.m. In case you want to try to compete for it, we have 78 total attempts. So that means 78 people at least made it. 78 total submits, which is pretty good, I'd say. Let's see how much people. 32 here. Um, but yeah, also check out the other lab questions. I feel like they're pretty fun. I feel like they're pretty cool. The goal of we don't have so many attempts for a lot of these, but it's a new type of question. It's a new type of learning mechanism, so I feel like it might take a second or two for people to start using, or people might never use it because they don't like it. I'm hoping it's the first one. The whole goal of all of these is going to be to basically do one of these. This question, lab number 8, where basically we would design our own optimizer. We'll probably start out with just simple stochastic gradient descent, maybe momentum. It gives us some like, oh, you could do any of these, or we could create something new. So maybe we'll try to create something new. But now I need to find that problem I was working on. Damn. Calculate Rubin's gradient descent. Is this it? Was. Oh, there we go. Let's see. Make sure everything's still running. Yeah, it's still running. Okay. So we were in the middle of solving this question. So we implemented batch gradient descent, so now let's implement regular old gradient descent. So if method equals, what is it, stochastic? Stochastic. So this time we're going through, so the difference between batch is the entire training set, stochastic is one at a time. So for, I'm pretty sure it says don't shuffle. Do not shuffle data, yeah, okay, so for, so I in, I really need to add the autocomplete to these things because it's annoying to, I mean, it's useful to write everything. Also I realize I always say, I mean, which is maybe annoying. I don't know if it actually is. We'll see if I catch myself doing that more. I'll try to do it a little less. So I'm gonna loop through this. Some iterations, we're gonna make a prediction. But this time, oh. So this time we're going one by one, because it's stochastic gradient descent, so we're taking one example. So for xi in x, I think I could do, where's my, so x is this, x is a list of lists. Weights, what do weights look like? The same shape as x, basically. Let's just take this and create this. Okay, yeah, you know I want to import numpy, then just do it. It'd be funny if you had an error handler, an AI error handler, you ran your code, and it would change anything it needs to change. So in this example, we'll just add numpy because it's assuming I made a stupid mistake. But also it would be very hard to catch bugs because if it assumes something and just runs it, that would really be hard to catch. So weight is that, and we have to, so x takes in these two, predicts that, these two predicts that. And we want to basically take each value of x, so that's this, and create a prediction, which should be x at weights dot transpose. If that work, let's just do it all here. Let's go for x underscore xi in x print xi. Let's make sure this is working. Okay, cool. Do I even need to do? Whatever. Weights dot transpose. Okay. That will give us our prediction. So our prediction. Now we have to go get our loss. Where was I? Okay, so we got prediction. MSE equals P dot. Just keep everything the same. Okay, we get mean squared error, but this again is for one example. I think all this should be the same, if I'm not mistaken. Except length of this should be length of xi, which is always going to be pretty sure this should be 1, but let's play around with this. I do not want to update stuff. Why don't I press skip update? I don't know. Because I'm scared that one day I will want to update it, and then I'll have to Google how to update whatever, and that will take a second. I don't know. I'm not sure why. I just X things out, but I do. Let's see. Prediction minus y. I don't know. I think this should just be 1. But we'll run and we'll see what happens. Why not? Okay, yeah, that makes sense. Let's just take this. We'll throw it down here. Just take the parts we want. So we have prediction. We want this stuff. Let's see where it breaks. Okay. Are we defining weights? I hate when it does this. Okay, so I'll define weights here. Would that make you find in another cell? Okay. xi is not defined. That is a fair error. I also realized I do this when I solve my questions, or this, which is something I didn't realize I did. I wonder if I do it when I'm not recording as well. I think I do. It's just always like, Let's see where I went wrong. Pretty sure this should be fine. Prediction. Oh. Minus y. Just do this. Should just call this I, to be honest. Let's say this is x of I. This is y of yi. I don't know why I'm doing this, even though I think it's wrong. I guess in case I... You know what? We're gonna just assume... I mean, I don't know why we're doing division. Okay. We're gonna try to use logic and hope my logic makes sense. And if it doesn't, then we'll get it wrong and we'll try something else. integer scalar. Yeah, and range length of x. Okay, we're getting somewhere. So you're saying the issue is with derivative of MSE. Fine. Let's decompose this a little. So prediction should be a single value. MSE should be a single value. MSE should be a single value. Derivative of MSE. I guess we don't need this transpose. Just because we're doing it with one example. It'll just be this. Does that make sense? Ugh. I had the old MSC definition before. That was nice. Stochastic gradient alpha times 2. Pretty sure this is what I'm doing. Pretty sure that's what I'm doing. Let's see if I'm right. But we will need to first format this a little better. We also need switch to another tab. So we'll need for underscore in range and underscore. I need to add autocomplete into this. Fine. I love how me doing this got both of them wrong. Just like, you know what? Yeah. Syntax error. Line 15. What's the syntax? Oh. Like, what did I do wrong? That makes sense. Oh, yay. Okay. I think now that we got the first one was annoying. I feel like second and third seem pretty easy. Should I do else if? Probably. And then just do else. So now we have mini batch gradient descent, which is, as we said yesterday, batch gradient, full data set, you're training for each step. Stochastic is training one example per step. Mini batch gradient descent is you're basically doing a small batch, which I feel like makes the most sense. Let's see, but now we have batch size. So for underscore, just copy this actually. Okay, so we have number of iterations. So now we need each. So basically this. But instead of that, we have batch sizes. So So what I'm thinking about right now is for the batch gradient descent, do we do it? When do we make the updates to the weights? I wonder. Let's see. Two over. So I guess we're doing, let's try for I, range, length of x. So we're going to be iterating by the batch size. Iterating by the batch size. Let's do this quickly though. I feel like I'm always unsure about small things like this. Oh, I wanted this. I2. Oh. This is a till. Okay, let's just. This gives us the length coolsies that we would want. X from I2 till I2 plus our batch size, let's call it 2. But this will eventually. Oh. Okay. So that's probably what we're gonna do. So where were we? Find range. Let's just do this. Make x. Do x. Let's redefine x. I till I plus batch size. And we'll have y equal the same thing except with y. I think this should break everything. I think this should not work. Division by 0. When would it, length of x? Oh, well this is not length of x. Oh, it is. Let's see. By mean prediction this squared. Fine. I don't think I need the hint, but I like to show off the hint. It's such a cool feature. Yeah. Fine. X underscore batch y underscore batch. So I think we were overwriting it and reusing it here, and it got messy. That's why you don't always try for these little stupid shortcuts that I do. But sometimes the little stupid shortcuts can save me barely any time. And you're asking, why do you do them then? And I'll say, I wish I knew that that's how I program. I think this should not work as well. Because why would it? I feel like this should work. I'm upset that it doesn't. Oh. think because the range is wrong, because this is going over it too many times. Method to mini batch instead of else. What? The method check should be mini batch instead of else. Why? Whatever. Batch creation logic is incorrect. You're creating a new batch starting at each data point, which causes overlap. Okay, yeah, there's overlap in them. Fine. Because I is 0, then it's 1, and overlaps it. We want this to be fine range. I think I'm not explaining things a lot today. I feel like I just want to solve this question. I feel like I'm frustrated that I didn't solve it yesterday. Basically, a little nice. Right now we're doing, so this is a batch of X. And theoretically what we want is to take a batch. Let's say this batch has 2 elements in it. 1, element 2. So that's batch 1. We pass that and we do the training and we update it. But right now, we're basically doing this is batch 1, and then this is batch 2, and then this would be batch 3, and then there's an overlap. So we would deal with that. I just forget how to do. Can I just do this? No. It's this. I guess so. Do I have to? Probably a better way to do this, but 0 till then, iterated by 2. And that's what we want. Fine. Fine, fine, fine. What if I do need to switch anything? Probably. Oh, this is. Yeah. Okay. And we did it. I mean, I probably should have switched things around a little, but whatever. Nice. One step closer to. Let's just go through the collection and do it there. Let's see. Optimizers. I also need to add new questions to optimizers. When you go here, you can see, 2/8 complete. Probably should add it here as well, just little check marks on what you finished. This one we just did. I want to check what the daily question is. We added this replace with an unsolved question for people that use the platform a nice amount. And as you see, it is broken sometimes, but I don't know why. Please solve the current daily question. I solved it. Did I need to solve it again? Oh, did I solve it? This count's sometimes used for like testing things out so things break. Let's see. Let's just continue here. I want to try and solve. Should I do? Yeah, let's do it after each iteration. I think I did stochastic gradient descent one of these times. Do I not have a regular gradient descent one? Gradient clipping, gradient checkpointing, optimization. Yeah, so I got a question. Is it free to solve? Yeah, you could solve as much as you want. There's some premium features, but yeah, all of our questions are open. All of them are solvable. We have collections of questions, which just makes things a little easier. For the daily question, you have access to problem breakdowns. That's everyone. For premium, it's every single question you have this for. For free users, you have for the daily question. It breaks down the question into smaller, easier to solve questions. Might not be needed for easy questions, but medium and hard, it's really helpful, in my biased opinion. There's also the hints, as you saw I used before. I'm trying to think any other benefits. Oh, so free users can have a limit to, I think they have 50 PyTorch and TinyGrad runs per day. Premium users have 500. So small things like that. A little faster run times, but I wanted people to be able to solve everything or anything they want here. I don't want to solve everything behind a paywall. Let's see. So, like these are premium collections. But all the questions are available to everyone. Oh, what I wanted to do. Keep on forgetting. Where is it? Labs. Okay, we're going to start on our labs journey of creating an optimizer. So, this lab we are given. I always get confused what I made states. State is weird. Is it? I think it's. If states is completely necessary. Okay, let's just try to do. If I actually talk about states here, I'm just going to do basic gradient descent. And yeah, so this is training against. Just look at some of the details. It's training against the MNIST dataset, a subset of it. This is the structure of the current dataset. It's a two-layer neural network. These many parameters, ReLU activation, pretty simple. Did I not mention? I guess I didn't mention the learning rate or batch size. Yeah, well, probably should add that in. Yeah, but let's try and just implement something and see what happens. Let's break something. Okay, I'm realizing an issue here. We can't really play around with this nicely. Oh, we also have something set up here where your code runs extremely fast, or at least for the run part, which we plan to implement for the whole website, but it's a nice testing things out here. Oh, this is good. This is what we want. Let's just shut this down. Let's delete this. Create a new notebook. Nope. Oh well, I switched my screen. How that's gonna look. Okay. So we need to make optimization stuff. That's our goal. And parameters theoretically look like given the parameters, I'm given the gradients. I'm given this state. Let me just check. Is this state needed? No, it's something given, and its first call is empty. And if I always keep it blank, we'll see what happens. Play around with it. Let's see. Then I'm going to do this rule. I guess I'm given the gradients. So it's just deciding how I want to use it. So is it as simple as, I guess I choose my learning rate. Say G for grad. What do I need to return here? New parameters and state. Okay, so rem times. Oh, so, okay. So this should be simple. Let me return rem2 and optimizer step rem grad. So this would be my updated. Okay, let's just do it here. Okay. Just trying to think how I want to do this. Trying to think, do I have one instance or is it multiple instances I need to do? I'm pretty sure it's multiple. Let's. I guess I can update them however I'd like. Let's just do something stupid simple. So this should be terrible. Let's see. Let's run it. Okay, 4 tests passed. Let's see what the tests were. The flow I have in mind for people is you run it, make sure it functionally makes sense, because you only have, I know it's less for free users, you have more validations and more submits. We plan to, once I make this a little more efficient, I'll roll out more for everyone. But for now, you're probably gonna have to keep it a little stingy. Let's see. Okay, let's validate this. Because once I know it logically works, so the validation trains it on a smaller subset of than the submit. Submit trains it on a larger subset and tests it against a larger subset. The validation trains against a small subset and tests it on a slower subset, a smaller subset. You have these cool graphics. I probably should have it. Whatever. Oh wow. So simple stochastic gradient descent gives me, at least on the validation set, 76.6% accuracy. That's pretty insane. Wonder. Okay, why not? Let's submit it. See how we do on the larger data set. But it updated quite well. Need to play around with. Oh wow. Oh. Pff. Oh wow. People really did well. Damn. Okay. The basic stochastic gradient descent got me on the almost passing. I like how it's not actually you have to do a little more to get that passing. I wonder if I just make things up. If I would eventually do better. Um, I guess I want a fun learning rate. So I want the learning rate. So you should have fast learning rate in the beginning and then slow down towards the end. I guess that's a learning rate scheduler. But I'm trying to remember, RMS prop does. I want to do it my own way. Pretty sure the higher the gradient, the if I have a high gradient, I don't need such a high learning rate. And if I have a low gradient, I need a high. So I think it was the learning rate divided by. Let's try this. This sounds interesting. So theoretically, let's see how this would work. Um, if the gradients are very high, this would be slow, so learning rate would be slow. If the gradients are very small, then the learning rate would theoretically go up. Okay, let's. Oh, why did I fail? What is this test actually? I should have like a little description of what this test does. Does this learning rate get passed? Oh, it does get passed in. So I'm just overriding it. That's fine. Let's see. Okay, so they're saying gradient is 0, and no momentum, as in nothing's in the state, which I guess we're clearing that there. It should stay similar. I mean, I feel like it's more of a good sanity check, but I don't think it's a necessity. Let's validate. Let's see how we do. I think it's a cool process. I mean, I feel like this is what I wanted from the labs, is just people to be able to implement things themselves. Like, any cool idea you come up with, like, oh, why are we doing this, or why are we doing that, or why don't we sum things up, why don't we... Okay, let's clear this. Let's try to revalidate that. It's still a little buggy, which sucks and annoying, but I think it's pretty cool. But I want people to be able to... I mean, yes, I could just implement stochastic gradient descent, momentum, R-swap, atom, and just go down the list of... What did I do? I don't know what this is. Go down the list, and and that's fine. You're learning well there. Am I breaking my thing? What's going on? Am I breaking something? Breaking something, it's not catching it? Where did I... Wasn't run because it had an error. It gave me no tips on my error. Oh, I guess if the grad... Let me add a small epsilon just in case. No, that wasn't even the issue. NP is not defined. It could be an issue. You just said it wasn't defined. You said it wasn't... What? Okay. We're just gonna open a new notebook and hope. Okay, let's... making my own things is fun, but getting caught up in the errors of the things I create is less fun. Okay. Let's see, so we have this. And let's assume, where is it? Let's give me the... Let's assume we have this information. And then we want optimize step. Someone let me know if I'm doing something stupid. I mean, I don't know if it's the best idea, but... So this is what it responded back. I don't see the issue. Maybe this was the issue? Let's try this. Oh. So that might have been the issue. Let's try and validate it and see what happens. Once I try this out, I want to show you guys a different lab question. Oh, cool. Yes, I'm very good at this machine learning stuff. Why did that destroy it? It's pretty funny though. That completely wrecked. I completely wrecked these results. What did I do? I just annoyed the learning rate, I guess. Say, why would this happen? Are we having an exploding gradient? Is the gradient getting too high? It's a possibility. So this is very low. Let's say I did this. It's at least that much. And even if this is very low, it's still a quite high learning rate. So if I did this, so it's at least that much. So at least that, okay. So I'm assuming what happened was this was very small. This was also very small. Once I did some. And I did. I feel like this is how back in the day old machine learning used to be done. No one really knew what was good or bad. They said, like, this sort of makes sense to me, and we tried it out and saw if it worked. Today, I mean, I feel like some of that and some of... I mean, still sort of that. I feel like the transformer architecture, there was no, like, this will work mathematically because X, Y, Z. It's, this seems cool. Seems like it would work. And tried it out. Seemed to work. Continue that path. Let's make sure this works. Let me make sure it's this way. Validate. I think this should do better. Because I think the gradient was exploding. Let's see if this is any better. Might be too low now because I'm summing, which is a pretty big increase. And I'm also adding plus 0.1. Okay. Okay. I forgot what I got last time. Sort of. Okay, it seems like a pretty low gradient. Let's see. Yes, it seems like it slows down a little too much now. So let's try our... Am I just hacking the validation set? Yeah, but I could hack the I guess I could get things wrong with the validation set. I mean, that's the point of it, to play around with. Like you see this big jump here, and then the learning rate slows down way too much. And if it slows down, meaning this is very big. So we have two options. We could either start this higher or lower this. I want to see. How many. I want to give everyone more access, more validation runs, because I know. I'm not sure how much the free plan gets, but I know it's not much. I want people to be able to experiment with it and not have to create their own environment to test these things out, which they could do, but it's just an annoying process then. Let's see. Okay. I guess I'm only going for 5 epochs. Epoch 1 is the best. Okay. So it needs at least 0.1, and I want to do mean, like the gradients. Okay, last run, and then I'll submit. If it has decent results, I'll submit the best, either sum or mean. See how it does, and then I want to show you guys one other cool question. I wonder if other people are like, wow, what a cool question. Or is it just me? Am I like, oh, okay, 89%. No one could see me pointing at my screen, but I pointed at my screen in excitement. Let's submit this and see how it does. So last time, oh no, we lost it last time. Last time we had like 84 accuracy, so we didn't even pass the minimum threshold. So hopefully, this one seems like it's at least going to be 89. 92.2. Where do I rank? Oh wow, people went for it. I wonder Adam. I mean, my assumption would be Adam would probably do the best, but it is. I think you're only training on like 3,000 data points, so maybe not. That's okay. That's pretty cool though. I feel like also maybe with more epochs it would do better, but I keep everything uniform so everyone has 5 epochs. Do with it what you can. The question I was talking about before, where is it? This one. This one I really liked. So this one, you have to keep your model with at least 30 layers, so it's a deep model. But, you know, you'd think, okay, great, a deep model, I probably will ace this. But because of, I guess, the vanishing gradients and just depth in general is a bit challenging. They talk about it in the ResNet paper. Like they normalize the inputs every layer, so I don't think vanishing gradient was the issue. But they still had an issue with very deep networks. So here, you're basically in the scenario of the creators of ResNet. So you need to either reinvent ResNet or read ResNet and implement it here, or look it up and implement it here if you want. I think you could also use DenseNet or layer normalization. I think use batch normalization, layer normalization, anything you really want. But I feel like it's the funnest part is you could do whatever you really like. You can do whatever you want. You could come up with a new method. Basically come up with a new method. I don't have a but this. But yeah, I'm enjoying the labs, and I feel like next time we'll do some more gradient descent, more of the optimizations. We also just have category optimization. There's also, I want to get to this. I want to do the muon optimization, whatever. Do cosine decay. There's a lot of fun things we could do with this. So we'll try to solve a bunch and see what we do. Anyone have any thoughts or questions or anything? Okay. Thank you guys for joining. This was fun.